Hi, my name is Mohammed Luqmaan and my matric number is 191473. Today we'll do a short presentation of how to do assignment, how we reach the graph obtained in the assignment number 3. So basically the question is the same as we did in test 1 of fluid mechanics, question number 2, where we were given the parameters shown on the right, such as the wing area, the wingspan, parasitic drag coefficient, and so on. And then at the end, we need to find the equation relating the V max, V mean the equation relating the speed with the power. And then we can plot a graph of the power V against TO. So power is, you can consider power to be also as in terms of the thrust, because the thrust is the one that provides power to an aircraft. It depends on how you want to plot the graph. So first of all, we're given the parameters, so we need to find the aspect ratio. The aspect ratio is basically the A square over S, which is the wingspan to the square, B square over S. So 35.75 to the square divided by 130. You will get the aspect ratio is equal to 9.8573262. Then using the aspect ratio, you can find the value of K. You find the value of K is equal to 1 over pi E, where E is the Ostwald efficiency from here. Pi is equal to 3.14, and the aspect ratio we just calculated. And then we get the value of K is equal to 0.038. The value of K is important because the value of K is used in the drag polar equation, such as CD is equal to CD naught plus KCL square. CD naught is given from the equation. So we have CD naught, 0.02. We know the value of K. We need to find the value of coefficient of CD and the coefficient of CL. How to do it? First of all, we need to find CL and CD. Lift is equal to, from John D. Anderson book, is half rho v square S CL, and drag is equal to half rho v square S CD, coefficient of drag. So this is our equation. So I won't quote all the equations from the John D. Anderson book, but at the end, the equation of power, PA is equal to D times V, where drag times V or thrust times D, thrust times V is the same. PA is equal to CD naught, which is given here. CD naught is already given the question, plus K. K we calculated the coefficient, and then multiply by 2 times weight over rho v square S to the square, because the weight is given. The weight is given in the question. It is 8. The weight is given. It can be 74 mass 80,000. So we can calculate the weight here. So the weight is given, and then the V, we need to find the V from the equation. This is the only constant that we need to find. So then, so in order to find the V, we need to find the value of CL and CD as well, which is very important. Then we can replace in the equation the one that we did in our class of fluid mechanics. Then we will reach this equation, we'll reach the graph. So what does the graph means? The graph is basically the relationship between the V and the TO or power, anything that you want. So here I calculate in terms of V. So then you will see that every time you increase the speed, you change the speed, there will be a new TO recorded. So this is a graph recorded. But what is important is the specific values that we wanted to have. Like from the assignment, we were given to find at a specific point at a specific altitude of 10,000 to find the relationship between speed and the rate of climb and so on. This is the speed, relationship of speed and the rate of climb of is from the graph of V against TO, because TO, as I said, is power, and power is energy per unit time. So we get the rate of climb, we get the relationship as well. And at a given altitude of 10,000 feet, this is a specific value we wanted to find. So as exactly from the test one, question number 2, we had the specific value as well. So then we just in the test 2, it was 160 horsepower. It was in terms of power directly. So we just had a horizontal line. Here in terms of altitude, 10,000 feet. Then we calculate the minimum max from the graph. We can see the V min and the V max. So this is basically about our assignment, where we need to find the relationship and so on. And this question is very important in fluid mechanics, because we did it in test 1, and we had practice questions to do about it, because It is one of the most important things in fabricating, because we need to know about the efficiency, how the planes wave perform in the air, the endurance, and so on. Endurance, it all depends on these factors, such as the coefficient of lift, coefficient of drag. So this is why this question is very important, and we had an assignment on it. Thank you very much, and hope you learn a bit from my explanation, and thank you very much. Have a nice day.